Alright, welcome back to today's class, stochastic process. My name is Sunday Oluwafemi Bodogbe. Okay, so today we will check the transition matrix. But before we check the transition matrix, I want us to check this example. Let me see, we have let's take note of this system weather. So let's say we have two weather condition. Let me put something here. Let's say we have raining represented as R, and then we have sunny representing as X. Okay, so this is a weather, and just assume that this is just the two configuration of the weather. These are the possible weather conditions we can have, just an assumptions. So if the current weather is R, so the probability that tomorrow's weather will be R, you can see the arrow, that is the current weather is R, and the probability that it will be R tomorrow is given as 0.4. That means that the probability that it will be sunny, the weather will transit from rainy to sunny, will be 0.6, because the addition of the two must give us 1. The current weather condition assuming is R, so the probability that it will be R tomorrow is 0.4, and the probability that it will be sunny tomorrow is 0.6. So let's assume that the current weather we have is sunny, so the probability that it will be sunny tomorrow is given as 0.3, and the probability that it's going to be raining tomorrow is given as 0.7. Okay, so this diagram, or a flow chart, whatever you may call it, is what we call our transition diagram. This is called transition diagram. So take note of that. So the simple definition is that the transition diagram is so called. We'll give a proper definition for you. It is so called because it shows the transitions between different states. Sorry. So here now the two possible states we have is our R, that is rainy, and then sunny. Okay, so this diagram we call it transition diagram. The arrow edge denotes the transition, that is this arrow edge going back to R means that it's moving from out to R. This going to this S means that it's moved from R to S. This edge arrow is meant that it moved from X to R, and then etc. So now this transition diagram, for us to actually work on it, maybe the analytical solutions, then we need to put it into a matrix form, and that is the next thing I want us to check. How can we now translate this our transition diagram into a form of matrix? So let's check now. There are matrix bracket. Okay, so you list your current state here. The two states we have, which is the current state, is raining or sunny, and that will denote your current state, that is S subscript T. Current state. Okay, so your future state also be R X. So we denote this as X index T plus 1. This here we call your future state. So let's go back to our transition diagram. So raining now. The probability that is going to transit from raining to raining. That is from raining to raining, that is 0.4. And probability that is going to transit from raining to sunny, that is this, that is 0.6. So if it is sunny, the probability that is going to transit to raining, that is this arrow, that is 0.7. And if it is sunny, the probability that is going to be sunny tomorrow again, that is 0.3. So this matrix is what we call our transition matrix. A better definitions will be given as we continue. So then I go properly to the definitions of transition matrix. So that's the note here. And then see now insert the transition probabilities. So, denoted as P index IJ. Next here, put in list of states. Now this that I talk about is subscript T plus 1. Here also in list of states in your row, the column, and this is X subscript C, your current state. So also take note that your rows add up to 1. Add to 1. Your rows add to 2, and your column need not to add to 1. Take note of that. So in the transition matrix is generally denoted in P. There we have the notation P subscript I just monitor. So let's write some basic characteristics of this transition matrix. So take note that the rows represent now or from article notation subscript C, and the columns represent next. Auto mathematical notation X index T1, and the entry I comma j is the conditional probability that next, which is equals to j, given that now equals to I. So we have as a statement that your P, the conditional probability, your Pij equals to given an x t plus which equals to j, shows that xt equals to I. Okay, so in the simple definitions, you can see that the transition matrix P of the Markov chain is P, capital letter P equals to P subscript Ig. So here we stopped today. So the next class will be checking out to set up the transition matrix. Thank you for watching. See you.